Students, welcome to my class. Today we will do some examples of connected bodies. Contact, and some bodies are moving over the pulley and some kept on the inclined planes. We will do a set of problems today. Set of applications. Let's start with the connected bodies. Okay, let's say two bodies are taken. As this body, or you say it is a block which has a mass of m1 in contact with another mass. Okay, it is a second mass. Okay, these two bodies are kept in contact with each other on a smooth surface. Let's say it is a smooth surface. It has a mass of m1 and it got a mass of m2. Okay, students, we have to find out the acceleration of the system when an external force acting on it, and as well as the contact force in between the two surfaces. Here it leads to numerous problems. You can add one more body to this. In this way you can connect a number of bodies, and every time you will find the tension, the contact force in between the two surfaces in contact, and as well as the acceleration of the system. Let's take two bodies and we are applying an external force on it. Let's say it is the external force which is acting on the body. Okay, students, here in this situation what we have to do? First we have to find out a contact force which is acting in between the two. Okay, students, let's name this contact force as T. Actually it is the pair of the two forces. We are taking these two forces by means of Newton's third law. To every action there must be equal and opposite reaction. And what force it causes on this body, this also applies the same force on. That's why we mention them as T and T. Both are acting in opposite direction. The force acted on this body is shown in this way, and it is here. Okay, students, let's say the two are in contact, that's why they are moving with a constant acceleration of a. To solve this, first we have to draw a free body diagram for this one. Let's say this was a free body diagram. Here the weight of the body W1 is acting vertically downwards. It balances with the normal reaction. Okay, students, additional to that, one force is acting in this way, and a tension force. Okay, that is the contact force. And for the second body, we have to go in the same way. Okay, it is the weight acting vertically downwards. Let's say weight V2, W2, and it is the normal reaction. Name it as N2, automatically it will be N1. Okay, and a force is acting on. It is the force, that means contact force, which is providing acceleration to this body. Okay, in this diagram, the two forces, that means weight and normal reaction, get cancelled with each other, and here also the same thing will happen. Okay, students, then after we have to treat these two bodies as a single system. Okay, if you apply the Newton law here, what we get? F is equal to ma to get the acceleration. Here m is equal to sum of the masses m1 plus m2. Okay, then F is equal to m of m1 plus m2 of a, and acceleration we got F upon m1 plus m2. It is the acceleration of the system, students. Then after we have to find out the contact force. See this body m2 is moving under the effect of this contact force T. This contact force T is making the body to move means what? It is providing the acceleration. Okay, then this force must be equal to the product of this mass multiplied with the acceleration. And I am writing the relation here. T is equal to m2 of A. Okay, students? Then just substitute the value there. It is m2 of acceleration F by m1 plus m2. In this way, we can find the tension and as the acceleration. Let's say m1 is equal to 5 kg. Okay, students, we are doing one example quickly. m2 is equal to 10. And we have to find out the acceleration. Just simply apply the formula. You can do it fastly. F by m1 plus m2. And applied force is, say, it is 15 Newton. Okay, students? F 15 by 5 plus 10. Then automatically it is equal to 1 meter per second square is the acceleration. In the same way, we can find the same. m2 is equal to 10 and it is F 15 by 10 plus 5. These two get cancels and we get tension which is equal to T. Okay, students, the tension force, that means what? The contact force which is acting on this body is equal to 10 Newton. In this way, we can solve a problem which has two masses. Then what about the system which has more masses? That means more than 2. Maybe it is a 3 or 4 or 5, whatever it may be. It can be done very easily. Say it, students. This time we are taking a 3-body system. Okay, let's say it is the first body and it is in contact with the second body, and we have one more, the third body. The 3 have been connected and kept on a smooth surface. Let it has a mass of m1, m2 and m3. Okay, an external force of magnitude F is acted on, then the system tends to move with an acceleration of A. As usual, we have to find out the contact forces T1 and as well as T2 here. Okay, students, let's find the common acceleration. As you know that F is equal to sum of the masses multiplied with acceleration, and we get A is equal to F by m1 plus m2 plus m3, and we have to go with the tension. We are finding the tension T2 here. This T2 is responsible for the motion of this block. That means it is providing acceleration. Then we can write it as T2 is equal to m3 multiplied with A, and T2 is equal to m3 acceleration we had. Okay, students, now is the time to find out the T2. See this, the difference between the two. Here T2 is in this direction, T is here. The difference between the two is providing acceleration to this black m2. Then we can write T1 minus T2 is equal to, it is providing acceleration to this block, m2 multiplied with the A, that is T1 is equal to T2 plus m2A. Already we had T2 as m3F upon m1 plus m2 plus m3 plus m2 acceleration of m1 plus m2 plus m3. Then we have to find out the T1 as what? m3 or m2 plus m3 of F upon m1 plus m2 plus m3. Okay, quickly we do a problem. Let's say m1 is equal to 2 kg, m2 is equal to 3 kg, and m3 is equal to 5 kg. Okay, and applied force F, say it is equal to 20. Then he is asking us what is the acceleration is. It's simple. A is equal to 20 of 2 plus 3 plus 5, 20 by 10, and we got an acceleration of 2 meter per second square. Maybe in examination he will ask you what is the tension between the two. Then automatically go with the relation. T1 is equal to what we get, m2 plus m3 of F by, okay, m1 plus m2 plus m3, okay, 3 plus 5 into 20 by 2 plus 3 plus 5, it is 20 into 8 by 10, 2s are 16 Newton. And we have to find out the T2. T2 can be had easily. It is equal to m3 into A. It's a smart thing. m3, what you gave? 5. And acceleration we got 2. Okay. In this way you can find out what is the tension and as well as the acceleration when in case of the 3 body system. And you have to adopt the same system for the 4 body or 5 body. Even it is pushed or pulled, you have to apply the same relations. Okay, students? Here, it can be asked in another way. See the students. Okay. Here, the same problem we are doing is a block 1, and we have one more block 2, the beam kept on a smooth surface, and it has a mass of m1 and it has a mass of m2, and these are the center of mass, and it is a line of action of the force. This time what is said, a force is acting in this way. Okay, students? Then he is asking us find the acceleration of the system and as well as the contact force which is acting the body. It is the force which is acting, making an angle of theta with the horizontal. He can give. Okay, and what you have to find? In this case you have to resolve the force into components. Okay, students, horizontal and as well as the vertical. Horizontal and vertical. It might be F cos theta and it is F sin theta. Here F cos theta is responsible for the motion of the body. That is, you can write F cos theta is equal to m1 plus m2 of A, and A is equal to F cos theta by m1 plus m2. Okay, students? In the same way we have to find out the contact force. As you know that T is equal to m2A. Here we are considering this m2 F cos theta by m1 plus m2. Okay, students? Quickly we do a problem by taking theta as 45. I'm taking theta as 45. Okay, and m1 is equal to 3 kg and m2 is equal to 2 kg. See what we did. First we have to find out the acceleration. F, here F is equal to 20 Newton. Okay, students, and put the values. What you get? A is equal to F cos theta by m1 plus m2. F 20 into 1 by root 2. Okay students, by 2 plus 3, that is 20, root 2 by 2 into 5, 2 is 2 root 2 meter upon second squared. Okay students, in the same way the tension can be had as M2A, that is M2. How much is it? 2 into 2 root 2, 4 root 2 Newton. Here one force is acting, making some angle with that you can do. Okay students, here this problem can be asked in another way. You have to follow the same. By giving 3 blocks or floor blocks, and might be it is asked in this way. It is a smooth surface, 2 bodies are kept here, and one more body we have. They are connected by a string. The string is massless and inextensible, and a force is pulling that body. Okay, he is asking us what is the tension in the string and acceleration of the system. You have to follow the same thing. Consider this one M1 and it is M2. You have to find the acceleration. A is equal to F by M1 plus M2. We got it? And we have to find the tension. T is equal to M2A. Okay students, then M2F by M1 plus M2. Okay, and sometimes maybe the question will be like this. He is pulling with a force of F, making an angle of theta, then automatically it is F cos theta, and you have to just change the values. A is equal to F cos theta by M1 plus M2. T is equal to M2F cos theta upon M1 plus M2. Okay students, here what we did, and we resolved this force into components. It is F sin theta and it is F cos theta. And how we resolve? Here you know about the resolution of the vectors. Let's say it is the force. Okay, and we constructed a triangle here, theta, and we are writing the components. Let's say it is Fy and it is Fx. Okay, Fx we have to find. It is, you know that cos theta is equal to what? Adjacent by hypotenuse. Fx by F, that is Fx is equal to F cos theta. It's a component of the force along the x-axis. In the same way, sin theta is equal to opposite by hypotenuse, that's Fy by F, and that is Fy is equal to F sin theta. Here it is. Okay, here in this way you can resolve the vectors into components and you can find out the desired results. Let's do one more problem students. It might be asked like this. Here it is related to the wedges. The two, we are doing the immovable pulleys. Let's say it's a wedge of inclination theta here, and we connected a pulley over this. Okay, a string is moving over. It is inextensible, the string, and the massless. Okay students, and these two masses are connected in this way, and he's asking us what is the acceleration of the system and as well as the tension which is present in the string. Let's say it is M1 and M2. Take M1 is greater than M2, students. M1 is greater than M2. And see the results. Okay, students. Here, if M1 is greater than M2, obviously it will move down with an acceleration of A. And tension would be like this. It's a tension. And it's the weight of the body which is acting vertically downwards. Here it is the weight. It is W2. Okay, students. We are drawing the free body diagrams of mass M1 and as well as the M2. Okay. FBD of M1. Okay, it's the point mass M1 and it is the weight of the body and it's the tension in the string. Okay. We said it is coming down, means the weight of the body is more than the tension. Weight is providing the acceleration. And you know that weight is equal to M1G. And we are writing the relation between the two. We are finding the net force. That is here, W1 is greater than T. Then the difference between the two, W1 minus T, give a net force. W1, it is M1G, minus T is equal to M1A. Let's say it is the equation 1, students. Okay. In the same way, we are drawing the free body diagram of the second. Okay. Let's see. It is the inclined plane making an angle of theta and the mass is kept here. Obviously, the weight of the body, W2, is acting in this way and it is the normal reaction. Okay, students. Here we are resolving the weight into components. It is M2G cos theta and it is M2G sin theta. Here we did before. You know that how to resolve the vectors into components. It is the theta. Okay. Let's see. It is the tension in the string. Here in this case, tension is making the body to move up. It is moving in this way. Okay. And we can write T is greater than M2G sin theta. Okay, students. Then T minus M2G sin theta is equal to net force, that is equal to M2A. Let's say it is the 2. We have 1 and 2. Adding 1 and 2. What to get? M1G minus T plus T minus M2G sin theta is equal to M1A plus M2A. Okay, students, here TT get cancelled and G of M1 minus M2 sin theta is equal to A of M1 plus M2, and we got the acceleration is equal to G of M1 minus M2 sin theta by M1 plus M2. In this way, you can find the acceleration. Quickly, we will do a problem. Let's take theta as 30 and put the values M1 and M2 are 2 and 5, and we will get the acceleration very quickly. Okay, students? In the same way, we have to find out the tension. Okay? We have to substitute this value A in one of the equations. Either it is or this. Okay, we are using, I'm taking this equation to find out the tension, students. Okay? See how we get M1G minus T is equal to M1A. Okay? And T, what to get? M1G minus M1A. That is T is equal to M1G minus M1. A we got G of M1 minus m2 sine theta upon m1 plus m2. Let's simplify. We can write it as T is equal to m1g into m1 plus m2 minus m1 squared g, okay, plus m1 m2 sine theta whole divided by m1 plus m2. And finally we can write T is equal to m1 squared g plus m1 m2g minus m1 squared g plus m1 m2 sine theta divided by m1 plus m2. And these things get cancelled, but we get gf, okay, m1 m2 is common. We can write it as m1 m2g of 1 plus sine theta by m1 plus m2. Okay, it's the tension in the string. We got the values of acceleration, okay, this one, and we had the tension. In this way you can find out the tension and acceleration, okay, in the string when it's kept on a wedge, that is immovable pulley we say. Okay, the results can be changed if you change the direction of the motion of the body. In this case it is moving down. Here think m2 is greater than m1 and we'll get the results. Okay students, let's go with one more. Here let's say it's a wedge, okay, and we connected a pulley here, and a mass is connected in this way, and it is one more. Okay students, let's say it is making an angle of alpha here and it is beta. Let's say it is m1 and it is m2. Okay, say m1 is greater than m2, then obviously the body will move in this direction with an acceleration, and it is the tension in the string, and here it is tension and the body will move in this way. Okay, let's resolve this one. It is the alpha and its weight is acting vertically downwards. Let's draw the free body diagram. It's an inclined plane and it is alpha. A body is kept over and it's the weight which is acting vertically downwards. Okay, we are resolving the weight into the components. Okay students, here if it is alpha, then it is the alpha. Automatically it is m1g, okay, sine alpha was this, and it is m1g cos alpha. m1g cos alpha is balancing with the normal reaction, and m1g sine theta is connected with the string which is providing the tension there. Okay students, here m1g sine alpha, this one, okay, if you watch it carefully you will find m1g sine alpha is greater than tension in the string. That's why the body is moving down. The difference between the two provides the acceleration, that is m1a, let's say 1. Now we are taking this plane. Okay students, is the beta, and the same body is kept here. It has a mass of m2 and weight is working vertically downwards. we are resolving it into components. Okay students, it is beta automatically, it is m2g cos beta, and it is m2g sine beta, and it is the tension, is the direction of acceleration, is the normal reaction. Normal reaction balances with m2g cos beta. The same thing which is happened here, n is balanced with m1g cos alpha. Here in this case also, T is greater than m2g sine beta. See the difference. That is T minus m2g sine beta is equal to m2 acceleration. Say it as 2, and we are adding 1 and 2. m1g sine alpha minus t plus t minus m2g sine beta is equal to m1a plus m2a. Here t get cancelled, and g of m1 sine alpha minus m2 sine beta is equal to a of m1 plus m2. Then we get a is equal to g of m1 sine alpha minus m2 sine beta by m1 plus m2. Okay students, with this equation you can find out the acceleration. If you substitute the acceleration, one of the equations, you will get the tension, and you can do the numericals also. For example, you say it is 37 degree and it is 57, then you can find out the acceleration of the system if you give the mass. Okay students, let's find the tension in okay, we are substituting the value of A in the relation m1g sine alpha minus t is equal to m1a. Okay, then it can be written as m1g sine alpha minus t is equal to m1 of g into m1 sine alpha minus m2 sine beta by m1 plus m2. Okay students, t can be had as, okay, what t we are taking it out, that is m1g sine alpha minus m1g of m1 sine alpha minus m2 sine beta upon m1 plus m2. Okay students, then you can write it as m1g sine alpha of m1 plus m2 minus m1 square g sine alpha plus m1 m2 g sine beta whole divided by m1 plus m2. Okay students, further it can be written as m1 square g sine alpha plus m1 m2 g sine alpha minus m1 square g sine alpha plus m1 m2g sine beta. These factors get cancelled, and what you get? 2 no m1 m2g sine alpha plus m1 m2g sine beta by m1 plus m2. Here we are taking m1 m2 g as common, that is sine alpha plus sine beta whole divided by m1 plus m2. In this way we can find out the acceleration. If he asks m2 is greater than, then you have to do the same case. Okay, the terms will change. Understanding, students? I hope you followed this lecture. If you think it is a good lecture, please subscribe my channel and share this video with your friends also.